Good evening, and I'd like to welcome everyone to the My Horse University and Extension Horse Quest live webcast on protein requirements for horses. The presenter this evening is Dr. Holly Spooner from Middle Tennessee State University. Dr. Spooner is an associate professor in horse science. As a clinical specialist for equine health, she teaches courses in equine nutrition and exercise physiology and conducts research. Her research interests focus on nutritional and exercise interventions to improve performance of the equine athlete. Dr. Spooner also coaches the stock horse team and assists with a nationally renowned horse judging team. Prior to coming to Middle Tennessee State University in 2012, Dr. Spooner developed the equine science program and served as an extension specialist at West Virginia University. In her spare time, Holly judges for the American Quarter Horse Association and shows and stock horse events. I'd also like to tell you that you are able to ask questions during the presentation via the text chat on the left of your screen. Our presentation will be recorded and we will upload it to our site tomorrow if you'd like to review the talk at a later date. And at this time, I'm going to turn the presentation over to Holly.
Thanks, Gwen, and thanks all of you for being here tonight. We appreciate your coming out to this e-extension in My Horse University webcast. I'd also like to introduce you to our question moderator for the webcast this evening. Miss Jenny Zambito will be assisting us with that. Jenny is a PhD student at West Virginia University in equine nutrition and equine exercise physiology. Jenny also received her Master of Science degree in animal science from West Virginia University, and prior to that completed her Bachelor of Science degree in animal science at Rutgers University. So we appreciate Jenny's help tonight, and again, if you have questions along the way, feel free to enter those into the chat box and Jenny will respond to you, or if I see the question, I'll try to include it into my presentation as well. So a little overview of what we will accomplish here this evening. We're going to begin with what is the role of protein in the horse's diet? What is a protein? How do we make up proteins? Then we'll talk briefly about how we supply protein to horses. Then we'll focus on what are the protein requirements of different classes of horses, everything from our brood mares and our young growing horses, all the way up to our senior horses and our athletic horses. And finally, we'll end with debunking some common protein myths that are out there in the horse industry. When we look at essential nutrients for the horse, and really for all mammals, we basically focus on 5 major areas. Water, the most essential, our energies, or our carbohydrates and lipids, which together make up our energy nutrients, then protein, and finally our vitamins and minerals. It's interesting, though, that while protein is essential, it's perhaps the most misunderstood, and oftentimes people tend to focus on it first when thinking about equine nutrition. And that may not exactly be where we should be placing our emphasis. In fact, I think it's interesting that if you ask most horse owners what they feed their horses, the first answer they're going to give you is something like, well, a 12% pellet or a 14% sweet feed, with that percentage being the protein concentration of that feedstuff. And hopefully by the end of this webcast, you'll have a little better understanding of why that doesn't exactly tell us the whole story. On a chemical level, or a chemistry perspective, let's first focus on what is a protein. A protein is a series of amino acids that are linked by peptide bonds. Now, what does this mean? On the right-hand side of our slide, you see a brief diagram. And if we look at this, we can see that there is an N, a C, and a C. And this is the backbone of this amino acid. That N is a nitrogen, and then we have 2 carbons. Off of this structure here, then we also have what we call an R group. And this R group is a chain that varies from one amino acid to another. And it's the difference in this that determines what protein we're dealing with, what amino acid we're dealing with. Aside from water, protein is the most abundant molecule in the human body. All tissues are made from protein. Everything from muscles and organs, as well as our enzymes, some hormones, such as growth hormone or insulin, and some antibodies, which help to aid in immune function. On the right-hand side this time, you can see a diagram of what a protein actually looks like once we string together some amino acids and allow it to twist into a configuration. So I keep saying amino acids, but what are those? Amino acids are the building blocks of proteins, and it's the order of amino acids that we string together that define what protein it is we're talking about, as well as what is the function then of that protein. Proteins can be very small, from just a few amino acids, to literally thousands upon thousands of amino acids linked together to form a large, complex protein. There are more than 500 individual amino acids, but interestingly, only about 22 of those work to make up proteins in mammals. Of those 22 proteogenic amino acids, or again, the ones that make up proteins, we find that there are 10 of them that we classify as essential. The remainders are classified as non-essential. An essential amino acid means that the animal is unable to make that amino acid in a high enough concentration to support daily health or daily living. The non-essentials can be made by putting together parts from other broken down amino acids. The essential amino acids for the horse that must be provided in the horse's diet include arginine, histidine, isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan, and valine. When we think about building a protein, or say making a protein that's going to be included in muscle, or if that's building a protein hormone, it all works the same. We build a protein by connecting these amino acids together. The easiest way to think about this is to think about stringing a necklace. If, for instance, we had a repeating pattern of beads that we needed to continue, such as dark brown, light blue, yellow, blue, tan, like you see in the picture here. And we needed to continue that pattern over and over and over. That's really how the body goes about making a making a protein. Now, if we run out of a certain color of bead, we're unable to continue building that protein. And really, things stop until that color bead can be resupplied, whether that's the next meal or whenever that certain amino acid can be provided again in the diet. So again, if that prescribed amino acid is not present, the stringing or the building of that protein must stop and the protein is not completed. We can't just substitute another color, like throwing in, for say, a red bead along the way, if that's not the color the pattern prescribed. The limiting amino acid, then, is an amino acid that's present in less than adequate amounts, thus limiting the protein synthesis. It's really that colored bead that we run out of first on a given diet. Typically, in the horse, lysine is accepted to be the first limiting amino acid. This is the same in pigs and some other mammals as well. Now, there is still some debate in the equine nutrition world about what, in fact, is the second limiting amino acid. Most folks these days have accepted that the second limiting amino acid is more than likely threonine, although there is still some evidence that it may be methionine. Let's think then about how exactly we go about digesting and utilizing proteins. When we feed the horse a protein, or we think about that beaded necklace, one of the first things the horse is going to do is to cut that string and release all of those different beads. This happens through enzymatic digestion in the stomach and small intestine, which we've abbreviated as SI. Pepsin is the main enzyme that is able to allow us to start this digestive process and is released into the stomach. In the small intestine, then, we have other enzymes that we refer to as pancreatic proteases that are released and will break down some of these other bonds, freeing up those amino acids. The amino acids, then, and some small dipeptides, or 2 amino acid proteins, can then be absorbed into the gut wall in the small intestine and into the bloodstream into what we call the amino acid pool that's then available for use throughout the body in building other proteins. Now, after the horse's small intestine, we have the large intestine. And while the large intestine might have some ability to absorb ammonia, most research indicates that the large intestine can't really absorb any proteins itself. This is of interest because any proteins that are contained in a plant cell wall may not be freed until they make their way into the large intestine. As the bacteria of the large intestine start to break apart those plant cell walls and free those proteins, the bacteria also synthesize other proteins, what we call microbial synthesized proteins. Now, it'd be helpful if these microbial synthesized proteins or microbial synthesized amino acids could be absorbed. But as I mentioned, most research indicates that this is likely not happening and that most of that protein contained in fibrous feedstuff really can't be utilized very successfully by the horse. This is quite different than a ruminant. In a ruminant, such as a cow or a sheep, microbial protein helps to meet most of the animal's protein needs because the first thing that happens to protein is that it is broken down by those microbes. That's also why most of our ruminants can utilize non-protein nitrogen sources, things like urea, which just provide a carbon backbone upon which we can make some of those amino acids. And so urea and these non-protein nitrogens are not going to be beneficial to the horse the way that they would be to a ruminant. If we look at protein digestibility, what we're talking about in digestibility is the ability of a feedstuff to be broken down into the absorbable units. The way that we examine this is to look at how much of a nutrient is fed, and then how much remains in the feces after it's passed through the animal. So we could talk about the digestibility of fiber, the digestibility of lipid, etc. But we're interested in protein digestibility. So when we feed a given protein, how much of it is the animal able to utilize versus how much of it makes its way through relatively intact? If we look at what we call total tract digestibility, or how much is digested during the full length of the digestive system, we see that alfalfa is about 73 to 83% digestible, while coastal Bermuda grass is a bit lower at 54 to 64% total tract digestibility. Concentrates and grains are going to have greater digestibility at about 85% or more. Now, we just mentioned that protein digested in the large intestine is likely not going to be very useful to that animal. So one of the things we probably want to consider is how much of this total digestibility is happening in the small intestine enzymatically so that we can get those amino acids into the pool and benefit the horses. That's what we call pre-cecal digestibility, meaning it happens before the cecum, thus in the small intestine. And that pre-cecal digestibility is going to be greater in concentrates and grains, just like the total tract, and usually that's going to be somewhere in the neighborhood of up to about 70%. In our forages, it's going to be lower, maybe only about 17% for some of our Bermuda grasses, and about 25 to 30% for our alfalfas. Because of these differences in digestibility then, as well as in the location where digestion and absorption is occurring, all proteins are not created equal. And proteins digested in the small intestine are said to have greater bioavailability. If we combine this with the idea of the amino acid profile, we get into the concept of protein quality, where a protein that is known to have a greater quality is going to be both more digestible as well as being made up of an amino acid profile that more closely resembles what the horse probably needs, meaning having more lysine, threonine, and methionine. Now, how do we supply protein? Many of us, if we ask that question, they say, well, in grains, or I give my horse a protein tub, something like that. But protein is present in all forages, grains, and concentrates to some extent. It's just to the level at which it's there, and to the level at which it's bioavailable and the quality of it that we need to be concerned. Many of our commercial concentrates, or the commercial feeds you may go by at the store, also contain some additional protein sources. Things like milk proteins may be added. Alfalfa meal is commonly added as a means of increasing protein, as are byproduct meals. At the same time, we can even include what we consider to be free amino acids, or amino acids that have been purified to really be a straight amino acid. For instance, sometimes you'll see that they've added lysine or threonine individually, and those will be listed on a feed tag. How do we evaluate that dietary protein then? Well, the best solution would be if we could look at the amino acid requirements in horses and compare that to the amino acid requirements that the feed contains. Unfortunately, we really haven't gotten there yet in equine nutrition. The amino acid requirements in horses remain largely unknown, except for lysine and a few of the other main ones. At the same time, very few feeds are analyzed for amino acids, or at least that amino acid profile is typically not provided and is not provided on the required feed tags. Instead, what we provide on feed tags is referred to as the crude protein percentage. The crude protein percentage is a percentage of how much of that feed is protein. Now, technically, they're not measuring protein when they evaluate this. What they're measuring is nitrogen, with the understanding that protein is mostly made up of nitrogen. So they take a nitrogen reading times 6.25 to obtain that value. Now, unfortunately, what crude protein doesn't tell us is what portion is digestible or bioavailable, or again, what that amino acid profile looks like. Crude protein is what we have, though, so it's what we have to use to evaluate the recommendations and whether our horse is receiving an adequate amount of crude protein. One of the first things that's important for us to understand is how we calculate the crude protein intake, or how much crude protein is being provided by a given diet. It's a fairly simple way to do this, and that's just to take the crude protein percentage in the feedstuff times the amount of the feedstuff that we feed, and that's going to give us the protein intake. For example, and we'll do this today in kilograms because that's the units we tend to work in equine nutrition, but along the way I've tried to include some poundages just so that you can probably wrap your head a bit around that more. So if we feed a horse about 12 kilograms of hay, that works out to be about 22 pounds, which is about how much we'd feed a normal average 1,200 pound horse on a minimum level. But if we took 12 kilograms and we multiplied that by 9% crude protein, or 0.09, we'd get 1.08 kilograms of protein. This is equal to 1,080 grams. If we fed 1 kilogram, or 2.2 pounds of a concentrate that was 12% crude protein, that would give us 0.12 kilograms, or 1,200 grams. If we added these two things together, that would give us 0.12 kilograms, or 120 grams. And if we add these two values together, that gives us 1,200 grams of crude protein that horse would be intaking on a daily basis. And it's this value that we're going to compare to the requirements for that horse. Now, when we look at protein requirements, where we're getting these values is from a book basically known as the NRC, which means the nutrient requirements, which is the nutrient requirements of horses, and it's a publication by the National Research Council. This publication is put together every 10 to 15 years by a group of the top nutritionists in the country, selected by the National Academies of Science to be part of this. And what they do is that they research any new research in the area of equine nutrition and compare those findings back to previous recommendations and modify those recommendations as necessary. So the NRC really is the holy grail of equine nutrition and what we're basing our recommendations off of for our different categories of horses. The latest update to this happened in 2007 and really was a good publication that we feel very confident in the recommendations made in this. The recommendations are going to vary according to the age as well as the use of the horse. So a horse at maintenance, standing in your pasture, not doing much work, is going to have a different recommendation than a horse that is either growing, than your broodmare, or then maybe our heavy exercising horses. We're going to start off with looking at the horse at maintenance. And again, the horse at maintenance is really the horse that's not growing, that's not lactating, or is not in late gestation with a foal. It's not doing a lot of work, maybe a few rides a week, maybe a recreational trail horse could still fall into maintenance, but kind of just that horse that's hanging out and not doing much. If we look at the NRC, it's going to tell us that that horse is going to require about 1.26 grams of crude protein for every kilogram in body weight per day. So a 500 kilogram horse, or about an 1,100 pound horse, is going to require 630 grams of crude protein per day. Now these values take into consideration most digestibility, or an average digestibility or bioavailability. So there's a fair buffer of safety here. So knowing then that that horse is going to require about 630 grams per day of crude protein for maintenance, one of the first questions we often get is, well, what % protein hay would I need to feed to meet this? Well, if we figure that horse at maintenance is probably going to consume about 2% of his body weight per day, we can answer this question. 2% of his body weight is going to work out to be 10 kilograms. Then we're going to say, well, what % do I need to multiply that by to get 630 grams? And the answer is 6.3%. So we'd need to feed that horse 10 kilograms of a 6.3% crude protein hay to meet his protein requirement. If we feed 10 kilograms of a 7, 8, 10, 12% crude protein hay, we've exceeded that requirement. This tells us that most horses at maintenance can easily be maintained on forage alone, at least to meet that crude protein requirement. We're not going to need to have any sort of supplemental protein source, whether that's a concentrate or a protein tub or whatever else that may be. That forage alone, if it's at least 6.3% crude protein, should be able to meet that maintenance horse's requirement. Moving then from the horse at maintenance, let's look at a horse during pregnancy or gestation. Our brood mares are going to be fed at a maintenance level through the 4th month of pregnancy. Earlier than that point, they're really not laying down enough tissue or needing the extra protein requirement to need to feed them differently. From about the 5th month of pregnancy through foaling, the NRC gives us an equation that takes into consideration the fetal gain. And so that's going to change as the pregnancy progresses. Early on, it'll be as low as about 0.16 kilograms per day, and then close to foaling will approach about 0.78 kilograms per day. And so if we do this along the way, what we find is that by about 9 to 11 months, we're probably going to need to consider providing a concentrate. By that point, most of our hays alone or our pastures alone are not going to meet that broodmare's increased protein needs. Now, typically about the same time, we also start considering a concentrate for the energy needs. And most of the time then, the protein provided by that concentrate will go ahead and fulfill that additional protein requirement. So we really don't have to think too much about it other than to say, as we begin to feed her more concentrate in order to maintain her body weight as she's growing that pregnancy, then we'll probably go ahead and take care of her protein requirement. Now, when that mare begins to lactate or produce milk for the foal, she's actually at a level where her protein requirements are going to be even higher because of the amount of protein supplied in the milk to that offspring. The NRC states that that mare is going to need about 1.44 grams of crude protein per kilogram body weight per day, and that's just going to help her in maintaining her body weight. And then she's going to need additional crude protein based upon her milk production. And really, we have about 50 grams of crude protein per kilogram milk, so if we multiply that by how much milk she's producing, we can get an idea of that difference. A 500 kilogram mare is going to produce about 16 kilograms of milk per day, depending on where she is in her postpartum period. So that's going to mean that the requirement is somewhere around 1,500 grams of crude protein a day. That's pretty different from about the 600 grams that we saw in that maintenance horse. Now, how do we make up that difference? Typically, feeding a concentrate designed for mares and foals, along with your normal hay or pasture, will meet or exceed this requirement. Most concentrates designed for mares and foals typically contain about 16% crude protein. So that horse is going to receive more out of that concentrate than they might concentrate at maintenance. And again, by feeding enough to meet their energy needs, we've typically have the protein requirement covered. Now, as we wean that foal and start to have that foal grow on its own using some of our normal horse feedstuffs, instead of being on the mare's milk, we have new requirements designed for that foal all the way up through about a 2-year-old. And this formula considers the average daily gain, or what we call the ADG, as well as the efficiency for the use of protein. Now you might be saying, what does this mean? Well, the average daily gain is just how much weight is that foal gaining. And that's going to be about 0.8 kilograms at 4 to 6 months, and then slow down as we get closer to 24 months of age to about 0.15 kilograms per day. The efficiency just refers to how good is that horse at being able to utilize the protein provided to it. And we actually have greater digestibility or efficiency for protein use in a younger animal than we do in an older animal. They're more efficient at being able to take in those amino acids across the gut because they've done so from that mare's milk along the way. And that protein efficiency then is about 50% at 4 to 6 months of age, drops down to 30% by 12 months, and holds out around that 30% mark as they approach 2 years of age. So, as an example, we see the equation written there below. And if we say a horse that is going to be 500 kilograms when they're mature, is a year old right now, it's going to have a daily gain of about 0.45 kilograms per day, which is going to be about 1 pound per day. The requirement then is 846 grams of crude protein. Now, if we think about feeding that horse forage alone, and it eats 2% of its body weight in forage per day, which is about the maximum you can get these youngsters to consume, and we had an average 10% crude protein forage, we can do the math and see that we'd only be providing 600, that should say grams instead of kilograms there, but we'd only be providing 600 grams of crude protein. So we'd actually be deficient in meeting that yearling's protein needs. This is why most of our yearlings and young horses cannot get by or cannot grow to their potential on a high rate of gain on forages alone. We typically need to provide some sort of concentrate to make up that difference. When we're thinking about feeding these youngsters, we also need to consider protein quality. Remember how we said that if they run out of that essential amino acid, even if others are provided, that protein building cannot continue. When we think about good high quality protein sources for the young growing horse, one of the more ideal feedstuffs would be soybean meal. And as we said before, some of our concentrate feeds typically utilize amino acids added individually directly as well. So it wouldn't be uncommon to see lysine indicated as an ingredient on the feed tag and added to help improve that protein quality. We also need to think about forage consumption. Most people greatly overestimate how much forage their horses, especially weanlings and yearlings, are actually consuming. Most of the time, our weanlings and yearlings will only consume, our weanlings will only consume about 1% of their body weight per day, and our yearlings, it's hard to get them to consume more than about 2% of their body weight per day. So if you have a 200 kilogram or about 440 pound youngster, they're only going to consume about 2 kilograms of that forage a day. It would take a very high crude protein forage to meet that difference. And also remember that those forages are not going to contain much protein that's going to be digested in the small intestine. So when we consider all of those things together, again, for most of our youngsters, we're going to have to utilize some sort of commercial concentrate in order to meet that protein requirement. I also like to point out in our youngsters that multiple meals may be more desirable, and the horses often have greater digestibilities when a more reasonable amount of a concentrate is fed at any given time. We typically like to keep that at about 0.5% body weight or lower at any given time so that we can have maximum digestion of that protein during the time it passes through the small intestine. I saw a question in the chat box regarding, is that all true even with alfalfa? And yes, it really is. While the alfalfa can meet the protein needs when we think about just crude protein, and if we feed enough of it, again, sometimes it's hard to first of all feed enough of it, but more importantly, is the protein quality there, and can it be digested in the small intestine where those amino acids can be absorbed? And if we think back to where we talked about pre-cecal digestibility, that was only still less than about 30% with our alfalfas. So I still have concern of getting enough of those amino acids absorbed in the small intestine with an alfalfa forage alone, and really with any forage alone. Transitioning then into the exercising animal. Once we've got this horse grown, now we're going to put him to work. The exercising animal does have an increased muscle turnover and does have increased sweat losses, which include protein losses, compared to a horse at maintenance. So the NRC has developed recommendation for horses in exercise. And what they've done is to just take the maintenance requirement and add to it a correction factor for exercise, or how much more is needed for a horse doing different amounts of exercise. If we look at these requirements, first it's important to know what defines the different levels of exercise. Light exercise is typically a horse that's going to work between 1 to 3 hours a week. This is often our recreational riding horses, maybe our trail horse we take on an occasional ride, and some of our not very hard-working show horses. Our moderate is going to be show horses that work a little harder, maybe our school horses, and these are horses that are going to work between 4 and 5 hours per week. Heavy exercise is 5 hours, maybe 5 to 7 hours of work per week, typically at a higher heart rate. Things like ranch work, where they're actually chasing cattle, cutting, eventing. Horses in the beginning stages of race training can all be in heavy exercise. Very heavy exercise is horses that are going to work at high heart rates multiple times a week, as well as do some slow work along the way. Typically, what we're thinking of here is our race horses, polo horses, and horses doing 3-day eventing. So for many of us, most of our horses are going to fall into the light category if they're doing anything other than maintenance. When we look at these along the way, what I've done here is to just look at the maintenance requirement and add to it how much this would increase our requirements if we had that same 500 kilogram horse doing the different levels of exercise. And we see that our requirement goes from 630 to 699 grams in that light working horse, up to 768 grams in moderate exercise, 862 for heavy, and to 1,004 grams of crude protein required for that very heavy exercising horse. Now, this might be surprising to many of you who might think that as a horse is exercising, we're going to see a huge increase in their protein needs, and that's simply not the case. We haven't even doubled the protein requirement with very heavy exercise. And if you'll remember back to that lactating mare, she in fact had doubled that protein requirement. Typically what happens when we think about the exercising horse is that we have to feed them more feed simply to meet their energy requirements so that they don't lose weight because of that extra work. And so that typically that increase in feed intake will go ahead and meet that increased protein requirement. So if we look at an example here, we have that horse eating 2% of his body weight in a 10% crude protein hay that's going to provide 1,000 grams of crude protein. That same horse eats 0.5% of his body weight in a 12% crude protein concentrate. That'll supply an additional 300 grams for a total of 1,300 grams of crude protein. So we very simply met that horse's and actually exceeded that horse's crude protein requirement, even for very heavy exercise. Because of this and how easy it is to go well above the horse's crude protein requirement for our exercising horses, we're actually starting to see some of our concentrates designed for athletic horses actually have a lower crude protein percentage. Because as we'll talk about in a minute, it may actually not be good to greatly exceed that crude protein requirement for these athletic horses. So now that we've examined the requirements, let's look at what happens if we don't meet these, and then if we exceed these protein requirements. In a case of protein deficiency, or not having enough protein, and actually we should say not having enough amino acid in the diet, what we see is that we have restricted growth in a young growing animal, and this is even despite adequate energy. So even if you're feeding enough calories and you're not seeing growth in a youngster, it could be the result of a protein deficiency. Some other signs of protein deficiency include weight loss, fetal loss if we're talking about mares, decreasing milk production in lactating mares, and in extreme cases, we can actually see horses reduce their feed intake and not eat if that feed is too low in protein. They can have poor hair growth and even reduced hoof growth, as both hair and hoof are comprised largely of excess protein fed through the diet. Now, you might be saying to yourself, well, I'll just feed lots of protein. I don't want to get into a case of deficiency. But actually, excess protein can be detrimental as well. And in the horse industry in the U.S., we more commonly see protein being fed in excess than we do protein deficiencies, except maybe in the case of those youngsters. What happens to excess protein? Well, excess protein cannot be stored. We can't simply pack it into the muscle or somewhere else in the body and save it for later when we might need it. Instead, excess protein is degraded or broken down. It's broken down into the carbon skeletons, which can then be put through and utilized for energy. And then the nitrogen mostly goes to urea, which passes through what we call the urea cycle and eventually comes out of the horse as ammonia in urine. Now, too much protein and using protein for energy is not a good idea. It is what we call metabolically expensive. And what that means is just that it's hard on the horse to utilize protein as an energy source. We'd be better off to utilize our carbohydrates and our lipids as energy sources. One thing I like to tell my students is that if you've ever known anyone who's done the Atkins diet, what they're doing is utilizing protein for energy. And it usually makes people grumpy and they don't feel well as the body starts to enter a ketotic state, and really it's just difficult and hard on them. So we try to avoid doing that to our horses. We don't want to feed too much protein and make them have to break it down. Now, it's also economically expensive. If you look at what's the difference between different types of horse feed, often the money difference comes in because of the protein difference. Protein is one of the bigger drivers of the price of feed. So by feeding more protein or a higher protein percentage feed than you may actually need, you're actually costing yourself money. It's coming out of your pocketbook. So it's metabolically expensive and it's economically expensive. All the more reason not to feed that excess protein. If that weren't enough, excess protein may also hinder performance. What happens is that it contributes to what we call acidosis, or lowers the pH within that athletic horse's body, which is going to cause that horse to fatigue faster and not have as good a performance. Thus, in the recent years, it's been suggested, again, that these athletic horses actually consume a lower percentage protein feed to avoid getting them into a situation of protein excess because of the extra calories required for their performance. Excess dietary protein can also influence calcium balance. If there's too much protein, that protein again can cause an acidotic state, which can then influence how much calcium can be absorbed into the gut of the young growing horse. My master's research conducted at Texas A&M examined this exact issue. And we did see differences in calcium balance when young yearling horses were fed more protein than NRC suggested. We didn't see a difference on out into bone quality, but if this were continued throughout that growing horse's life cycle, it certainly could influence bone quality and cause breakdown in some of these youngsters. And finally, as the horse industry comes under growing environmental fire for our contributions to polluting the environment, we have to think about excess protein, because that excess protein is going to come out in the form of nitrogen, and that additional nitrogen loss that we don't need is going to go eventually into our environment. So there are environmental factors that we should be concerned about as well. So we can see then that our goal should be to meet that horse's protein requirements, but not necessarily to exceed those requirements. And finally, let's transition into looking at some common protein myths. The first myth that I've alluded to before, and we should all know the answer to, is that all horses need a protein supplement. Hopefully, we did a good job this evening in helping you to understand protein, and that many of our horses, particularly those at maintenance and those maybe doing light work, can likely survive and meet their protein requirements on a forage, meaning hay or grass diet alone, and don't actually require any sort of protein supplement, whether that's a tub or a concentrate. The next myth that I often hear is that, well, feeding more protein builds top line. Protein is not discretionary. It can't go in and give your horse more gaskin muscle or more forearm or build more top line. Sure, if a horse is deficient in protein, it may look weak over its top, but its muscle is going to look weak everywhere. Typically, top lines are built through training and having that horse collect himself, and really don't have much to do with the protein in that diet in particular. It's going to be more reflective of fitness. The next one I hear is that too much protein makes horses hot. If you remember, we said protein can be an energy source, but it's actually not one that we would implicate in making a horse have a hot disposition. That would actually be more sugars and starches. Now sure, if you feed more of a concentrate that contains both protein and sugars and starches, your horse may become a hotter temperament, but it's not the protein doing that. Just like you wouldn't have a young child that you give a hamburger to and expect them to be hyper. It'd be more that candy that they had after dinner. And finally, exercising horses need high protein diets. Hopefully we've helped you to understand that the exercising horse does have some increased protein requirement over the horse at maintenance, but that increased protein requirement is typically exceeded by feeding more of our normal athletic horse concentrates that we'd need to supply that extra calories or energy to the horse. And in fact, it may be more beneficial to that exercising horse to consume a lower protein diet or percentage of protein in his diet that will just meet and not exceed his energy needs. So in summary, protein, or more correctly, amino acids, are necessary in the diet for normal body function and have many important roles. Crude protein requirements are utilized in equine nutrition, and the different crude protein requirements are going to differ by class of horse. And we've examined some of those for maintenance horses all the way up through our athletic horses. I would direct you to the Nutrient Requirements of Horses publication for the NRC for more specific requirements. Or talk to your extension horse specialist, your feed company's nutritionist, to help you in determining a more appropriate ration for your animal. But knowing that we should strive to meet protein requirements, not to exceed those. Some additional resources include the eextension.org/horses website, the My Horse University Equine Nutrition course, as well as the NRC actually has an online program available at the link shown there that you can actually go into, select your different categories of horses, and see just what their requirements are. And you can also play around with different feedstuffs and how much feed it would take of those feedstuffs to meet and exceed those horses' requirements for protein, energy, and vitamins, minerals, etc. With that, I'd like to thank you for your attention today. And if there are a few other questions in the chat box, we'd be happy to answer those. It looks like I see a question of how can hay be tested to determine its protein content? And the answer to that would be the same way it's tested for all of our other nutrients, meaning that we obtain a sample that's sent into a laboratory, which again does an analysis for the amount of nitrogen in that sample, and then we'll provide those results to you. And then depending on your needs, they can also analyze for sugars and starches. They'll provide different measures of the fibers as well. And so that will give back to you the amount of protein in that hay. Jenny's mentioned that Equa Analytical is a commonly used company for that. Many states' extension services also offer hay testing, and your feed company may offer that as well. With that, we'd also like to remind you that you will receive a survey to give us some feedback on tonight's presentation, and also has some questions on suggestions you may have for upcoming webcast from eExtension and My Horse University. We have here some of the upcoming webcasts. Our final in our nutrition series is on energetics, specifically focusing on lipids and carbohydrate portion of the diet, and that'll be from Texas A&M's Dr. Dennis Ziegler on November 27th. And then we're going to move into a session looking at horse behavior with horseplay, and then a review of cribbing, weaving, and other stereotypic behaviors. With that, I'll turn it back over to Gwen.
All right, well, we definitely like to thank Dr. Spooner for her presentation tonight, and of course, we'd like to thank all of you for participating in our webcast as well. As mentioned, please make sure as you're going to see a survey come to you through your email, and if you could give us some feedback, we'd really appreciate it. And you can always check out what's going on at My Horse University and E-Extension at our website, myhorseuniversity.com. And of course, we're on Facebook and Twitter for some up-to-date information on our events and our courses and more. And one last thing I'd like to remind you all is that I did record this webcast tonight, and we will be uploading it to our website tomorrow. And feel free to send us any of your comments or suggestions to info@myhorseuniversity.com. And it does look like, I think we've got one more question here from Judy. So I will turn it back over to Holly for just a second here.
Thanks for your question, Judy. The protein content in your hay can vary fairly drastically from cutting to cutting. It's affected by largely the fertility of your soil because, again, remember that what we're talking about is what we're actually measuring is the nitrogen content. And so different hays and even different cuttings, even different areas of the same field can be different. So your best advice is actually to either test every cutting and in doing so take samples from different areas of the field, or if you can only do one hay analysis for a given year, at least try to make sure that you're including hays from all the different cuttings so that you have really an average then that you can develop the best diet around. And with that, again, thank you all for coming, and we hope you'll continue to tune in to My Horse University.